Hello all, welcome back to the series on static timing analysis. So in our previous session, we have calculated the setup time as well as hold time, and we have derived the equations for the setup time and hold time without considering the skew. So in this session, we will calculate the setup time and hold time by considering the skew. Okay, by considering the skew. So we will first consider with positive skew, and after that we will calculate the setup time and hold time with negative skew. Okay. So first let us start the calculation of setup time and hold time with positive skew. Okay. So with positive skew, let us consider this setup time and hold time. So first let us calculate the setup time. We'll consider the same circuit which is given in the previous session. So let me draw that quickly. So I hope you have remembered this, what is meant by positive skew and what is meant by negative skew. So if you are not aware of about this positive skew and negative skew, please refer my previous sessions where we have discussed about positive skew and negative skew in detail. So this is clock D Q Q bar clock pin. Sorry, here the clock is connected, and with a buffer is connected to this clock, right? So with a combinational circuit, it is connected. So the data flow is from flip flop 1 to flip flop 2. This is the data flow. Now, so let us say this is the clock which is given to our flip flop 1. This is the clock which is given to our flip flop 1, right? And let's say this is having a propagation delay of 2 nanoseconds. It is a combinational circuit, right? So after 2 nanoseconds delay, the clock will reach to the flip flop 2, right? So this is the clock which is going to flip flop 2. This is the clock which is going to flip flop 2. So you can observe here there is a time difference. This time interval, this difference is called skew. So this is a positive skew. This is delta. Let's represent this with the help of symbol delta. Okay, this is Q, positive skew. Now, so let us consider the setup time for this flip flop 1 is somewhere here, and hold time is somewhere here. Similarly, for flip flop 2, the setup time is somewhere here and the hold time is somewhere here. So this is the setup time and this is the hold time, right? And here you can observe this is the setup time and this is my hold time, right? So we are discussing about the setup time, so we will start with the only setup time discussion. So setup time with positive skew, right? This is our discussion of now. So how to calculate the setup time? So when we are getting the data to flip flop to what is the arrival time. So in previous video if you watch, we have first calculate what is the arrival time. That is the data which is reaching the flip flop 2 from flip flop 1. What is that arrival time? That is same, right? So there is no change in the data path from flip flop 1 to flip flop 2. There is no change, right? So the arrival time is same. Okay, so it is nothing but t clock to q plus t combinational, right? So this is the arrival time at flip flop 2. So the data is reaching at after the time interval t clock to q plus t combinational to the flip flop 2. What is the required time? What is the required time here? So previously, how we have calculated the required time? So previously, what was the clock which is given to flip flop 2? I'll draw the clock for your reference. So this was the clock which is given in the previous session without skew, right? So what was the required time? Required time was calculated by subtracting this time period t clock minus t setup, we will get the required time. So the skew, so the setup time for this was somewhere here. So the required time was calculated by t clock minus t setup. So it will be required time will be we will be getting here. So this was the required time. Okay. So this is how we were calculating the required time, right? Now let me erase this. So now what is the required time for flip-flop 2? So we should get the data before this setup time, right? So we should get the data before this setup time, that is a requirement. So how to calculate this required time? Simple. So the what is the time period of this clock? This is T clock. Okay. And we have the difference. This is positive skew, right? Here we have the this time interval also we should consider. This is delta. Previously we don't have this delta factor. Now we are adding this delta factor. So we should subtract t clock plus delta minus t setup. This time interval is nothing but t setup, right? So we should subtract minus t setup. Then we will get this time, right? Then we will get this time. The time interval, the data should be reached to flip flop to avoid setup time violation. Then we will get this time. Okay. So what is the required time here? T clock plus t clock to q, t clock to q. Sorry, my mistake. T clock plus delta minus t setup. This is the required time. We should get the data. So before this time interval, the data should be arriving. Okay. So what is the requirement? Same like in previous session, the arrival time should be less than the required time. Then only there will be no setup time violation rate. Then there will be no setup time violation, right? So what is the arrival time we are getting when we are getting the data? We are getting at t combinational plus t clock to q, which is less than what is the required time? T clock plus delta minus t setup. Okay. So we will bring this left side. So t combinational plus t clock to q plus t setup minus delta, which is less than or it may be also equal to t clock. Okay. So this is the requirement. T combinational plus t clock to q plus t setup. Here there is one more factor, skew factor, that is delta, which should be less than or equal to t clock. So previously we don't have this delta. Now we are adding this delta because there is a positive skew, right? So here you can observe, if let's say without skew, we will write this t combination is 2 nanoseconds, t clock to q is let's say some 1 nanosecond, and t setup, let's say it is also 1 nanosecond. Okay. And let's say the time period t clock, and let's say that, wait a minute, let me write it again. T combinational, let's say it is around 2 nanosecond, t clock to q is let's say 1 nanosecond, and t setup, let's say it is also equal to somewhere 1 nanosecond, and t clock, time period of the clock, let's say it is 4 nanoseconds. Okay. So to avoid the setup time violation, what is the equation we have? T clock to q plus t combinational plus t setup should be less than or equal to t clock, right? So if we substitute the values, then we will get 2 nanosecond plus 1 nanosecond plus 1 nanosecond, which should be less than or equal to 4 nanoseconds, which is true, right? 4 nanoseconds is less than or equal to 4 nanoseconds. So there is no setup time violation, right? So let's maintain this delays the same, and we will add the skew factor. Okay. So let's add the skew factor delta is equal to, let's say, 1 nanosecond. There is a skew of 1 nanosecond, right? So what happens now? 1 nanosecond plus 1 nanosecond plus 2 nanoseconds plus what is the skew? 1 nanosecond. We should subtract, right? What is the skew equation? Minus skew, right? So we will subtract the skew. Minus 1 nanosecond is less than or equal to 4 nanoseconds. Then when we should get the data? 2 nanoseconds plus 2 nanoseconds minus 1 nanosecond. So which is nothing but 3 nanoseconds is less than or equal to 4 nanoseconds. There is no setup time violation, right? And let's say if this combinational circuit delays 3 nanoseconds. So what will happen in this case without skew? If it is 3 nanoseconds, then 3 plus 1, 4 plus 1, 5. There is setup time violation. But if we add the skew in the same scenario with T combinational is equal to 3 nanoseconds, then what happens? 3 plus 1 4 plus 1 5 minus 1, it will become 4 nanoseconds, right? So you can observe here with the addition of skew, that is positive skew, the setup time violation is being removed, or we can say with the addition of skew the timing restriction, it gets somewhat eases, so that there, so if the skew increases, it will basically ease the timing restriction for the setup time. Okay, so what is the benefit of this positive skew is with the addition of this positive skew, there is a ease in the timing restriction, right? And it is also increasing the frequency of data. Increase of frequency of operation of data, right? With this example only you can observe. Previously without skew, when the combinational delay was high, there was a setup time violation. But with increase in skew, what is happening? It is getting decreased. The time at which the data should reach the second flip flop is getting eased. Okay, that is decreasing, right? So this is how we are, with the help of the positive skew, we are able to ease the timing restriction. With the waveform diagram also you can observe what happens is, so let's say this is our clock. Okay, so let's say this is normal without skew. Okay, and let's say this is with skew, right? So this is with skew. So let's say this is the setup time for second flip flop. Okay, so for this second with skew, right? So here there is a setup time, right? So what is the requirement? The data should be present before this setup time, right? So this is the case without skew. So this is the data. This is the clock for flip flop one. This is the clock for flip flop two. Okay, this is without skew, and this is the clock for flip flop two. This is with skew. So where we are having the setup time? Somewhere here, right? So let's say the data is reaching the flip flop 2 from flip flop 1 somewhere here. So it is taking this amount of time. So the data will reach the flip flop 2 somewhere here. So in this first case without skew there is violation rate, setup time violation rate. But if we add the skew, then what happens? There is no change in the arrival time of the data, right? There is no change in the arrival time of the data. So the data with skew also reaches here only. Okay, but you can observe there is no setup time violation. With because of addition of skew, there is no violation of setup time. Okay, so this is how the skew is helping us to avoid the setup time violation. So this is about setup time check with positive skew. Now let's consider the whole time check with positive skew. Now what is the arrival time? That is same, that is not changing. When the data is reaching the flip flop 2 from flip flop 1, that is same, that is t clock to q plus t combinational, right? And what is the required time? We will see with the help of waveform. This is the clock for flip flop 1. Let's see the clock for the flip flop 1 without any skew. And the clock for flip flop 2 with skew, right? So this is the amount of skew which has been introduced. Delta flip flop 2 with positive skew. Now, so previous, let's say the whole time is this t hold, t hold, and we'll get the data somewhere. So this is the t hold, right? So the data which is getting to flip flop 2, let's say the setup time is this, then the data will get somewhere here, right? So it should be constant throughout this t hold. Or here for the flip flop 1, let's see here, the data which is given to flip flop 1 should be constant minimum amount of time. This minimum amount of time, it should be constant, that is this during this t hold it should be constant. So without skew, what we have considered, what is the requirement? Required time was t hold, that is this minimum amount of time the data should be constant. This is what we have considered. But in the case of flip flop 2 with skew, this is the t hold, right? This is the t hold. Then what is our requirement? The data should be constant here, t hold plus delta, right? So the main factor delta has added. So with skew, what is the requirement? Here the data should be constant with what is the requirement here? Requirement is the data should be constant with t hold plus skew. Okay, so this is a requirement. And for avoiding whole time violation, what should we do? Our arrival time should be greater than t hold, sorry, required time. Okay, that is t clock to q plus t combinational should be greater than required time. What is the required time? T hold plus delta, right? So the data here also you can observe that is delta and this is t hold. So the data which is given to flip flop 2 should be constant, should be held constant during this whole time interval, delta plus t hold, to avoid whole time violation. That is arrival time. So the next data when it should come after this delta plus t hold. So during this delta plus t hold, it should be constant. That is a requirement. That is arrival time t clock to q plus t combination should be greater than t hold plus delta. So this is how we will calculate the, this is the equation for whole time with skew. Okay, now let's consider some random values for this t clock to q and t combination. Let's say this 2 nanoseconds, t combinational is, let's say, 2 nanoseconds, and let's say t hold is around 5 nanoseconds, or let's say it is 4 nanoseconds, right? 4 nanoseconds plus 2 nanoseconds. So we will consider without skew. Then what happens? T clock to Q 2 nanoseconds plus T combinational 4 nanoseconds, which is greater than 5 nanoseconds. There is no hold time violation. Now, with the addition of skew, then what happens? We are not changing any values. 2 nanoseconds plus 4 nanoseconds should be greater than 5 nanoseconds plus, let's say, our skew is 1 nanosecond plus 1 nanosecond. 6 nanoseconds is greater than 6 nanoseconds. This is not true, right? So there is hold time violation. So you can see, you can observe here with the addition of skew, there may be a chances of hold time violation. So the data should be held constant for more longer time. So that's why if we decrease the skew, then there will be, if we reduce the skew, then the timing will be good and there will be no hold time violation. But if we increase the time, if we increase the skew, then there will be hold time violation. Okay, so this is how skew is affecting the hold time violation. Positive skew is affecting the hold time violation. So this is how positive skew is affecting the hold time violation or hold time and setup time. Basically, positive skew is helping for to avoid the setup time violation, but whereas the positive skew is not helping us to avoid the hold time violation. Actually, it is bringing us hold time violations, right? So this is about the setup time and hold time calculations with considering positive skew. So that's all for this session. Thank you.